Okay, hello class. So, in today's video, we're going to be talking about a formula that we have for slope. So, in class period, we took a look at the geometric representation of slope, horizontal and vertical change, and how to calculate slope from a graph. Now, you can also calculate slope algebraically given 2 points. So, in order to calculate that, first we're going to look at something a little bit more familiar. What happened if I was to ask you what the distance between 2 inches and 5 inches on a ruler? And this is a simple operation I'm sure everybody did in their head. You might have even said 3 inches to yourself before you realized what operation you were using. We looked at this a little bit when we were looking at absolute value. And that the distance between 2 and 5 is simply just the most positive point. 5 subtract 2. So the operation you're doing is subtraction. 5 subtract 2 is 3. Same sort of thing follows when we're talking about the formula for slope. In that, for any 2 points, x1, y1, and x2, y2, the slope of the line containing these 2 points is, and the formula for slope is y2 minus y1 over or divided by x2 minus x1. Now, something to keep in mind, in that these 2 points, I said x1, y1. Another way you can say it is x sub 1, y sub 1, x sub 2, and y sub 2. These numbers are called subscripts. They're not numbers that you're multiplying, dividing, add, subtracting. You're not doing any operations to these numbers. It's just a way to differentiate one point from another. So one point is the x1, y1, so we use the 1s, and one point is the x2, y2, so we use the 2s. So we'll look at how they differentiate in a little bit, and we'll identify them on the x-actual graph between points A and B. But the slope is just simply one y value of one point subtract another y value. And you have to take care that when you put something first in subtraction, so when you're subtracting y1 from y2, you then have to take that same coordinate point, except part of the coordinate point, that x1, that's coupled with y1, and then subtract that from x2. So we'll take a look at that, what I mean more specifically about that in a minute. But essentially, whatever you put first in the subtraction problem for y, you have to then put that first for x. So you have to put x2 and y2 first, and then x1 and y1 first. All right, so if I call point A to be x1, y1, so we'll say that this is point A. That means that this coordinate point, point A, is -4, 0. x2, y2 will then say is B, and that is 0, 6. So we have 2 coordinate points. I'm saying that x1 and y1, or at the point x1, y1 is -4, 0, and the point x2, y2 is 0, 6. So how do we put this in the formula for slope? So when I said make sure to take care to put them in the correct order, what I mean by that is this. If I say my formula for slope, y2 minus y1 over x2 minus x1, y2 here is the coordinate point in the y-coordinate of x2, y2, or 6. y1 is 0, so then I do 6 minus 0. So that is this 6 here, and that 0. Over, and when I said that you need to put x2 first, meaning that if I put 6 first in the point 0, 6, I then need to put the x2 coordinate point, which I'll circle in green, this 0 first. So I can't do -4 minus 0. I put 6 first, so I need to put 0 first. And then I do 0, and then minus a -4. Okay, so another difficult part about this is that when you need to be able to know that when I subtract a negative, that changes to addition. So in the numerator, 6 minus 0 is 6. 0 minus a -4 converts to being 0 plus 4. So the denominator is 4, which reduces 2 because they both have a common factor of 2. Divided by 2 is 3, divided by 2 is 2. So my final answer for my slope is 3/2. So in this way, I've been given 2 coordinate points, -4, 0, and 0, 6, and then I can generate algebraically or using a formula by using subtraction the slope, 3/2. All right, so let's take a look at a couple more practice problems involving this concept. This time we won't be given the graph. So what's the slope of the line, the segment of the line, through the points -3, 5, and 2, 11? So once again, we're using the formula for slope, y2 minus y1 over x2 minus x1. And I'm calling x1, y1 to be, let's say, -3, 5, and x2, y2 to be 2, 11. Therefore, if I'm doing y2 minus y1, y2, 11, y2 being 11, I'm doing that first, so that is 11 minus y1 is 5, and x2, the x-coordinate of x2, y2, is 2, and no, not a comma. My calculation then is 2 minus a -3, -3 being x1, the x-coordinate of x1, y1. So 11 minus 5 is 6, and 2 minus a -3 is +5. My slope is 6/5. Okay, we'll do one more, then I want to show one more thing before I ask you to do one, problem number 3. So I won't put the formula for slope or detail x1, y1, and you should be sort of getting used to doing it in this format, at least eventually. Just given these 2 points, I can then say, I'm going to call y2 to be, in this case actually let's label x1 and y1 and x2 and y2. So we'll say x1, y1 is 2, -8, and x2, y2 is -4, 12. All right, so my slope then is therefore, this is -4, 12 minus a -8 over x2 minus x1, -4 minus 2. All right, so 12 minus a -8 is 20, and here's where our skills quizzes are coming into play, and we know we need to know how to add and subtract positive and negative numbers. -4 minus 2 is -6, but we're not done. That fraction can be reduced. Both these numbers have common factors of 2, so when the common factor is 2, we divide 20 by 2, that's 10, -6 by 2 is -3, and my final result for slope is -10/3. All right, so something I want to point out is that it doesn't matter which coordinate point you choose to be x1, y1, and which one you choose to be x2, y2. And that I'm going to do the exact same calculation, except switch these 2 coordinate points, call x1, y1 to be -4, 12, and vice versa. So just to show you that the same calculation works, and it doesn't matter which one you call x1, y1. I mean, you can just, in the problem, whichever one comes first called x1, y1. That's what I always do. But, you know, technically it doesn't matter. So I'm going to take these 2 coordinate points and reverse them. In that, I'm going to call x1, y1 now to be -4, 12. Previously it was 2, -8, and then 2, -8, x2, y2. So in my formula for slope, now I'm saying -8 minus 12, y2 minus y1, over 2 minus a -4 would produce the same result. -8 minus 12, -20, 2 minus a -4, +6. You see you got the same fraction that we have to reduce. -20 over 6 also reduces to -10/3. So once again, it doesn't matter which coordinate point you choose to be x1, y1, and which one you choose to be x2, y2, as long as you sort of match that x1, or sorry, put the y2s, whichever one you call to be x2, y2, put that first in the subtraction statement, and then subtract the x1, y1 from those numbers in the numerator and denominator. Okay, so I want you to do the your turn problem. That's number 3. So the slope of the segment through 0, 3, and 5, -3. I want to see that on everybody's paper and on their homework when we collect it. If you don't put that, then you will be marked down for your homework. So make sure you do the your turn problem. Okay, thanks very much, and we'll see you guys in class.